So in terms of logarithms, let's go ahead and get this copy down. Like I said, this is just going to be today is basically an introduction to logarithms and being able to understand or compare logarithms with exponential functions. Logarithms and exponential functions are what we call inverses of each other. In other words, they will undo each other. So we're going to be using them hand in hand. So finish copying this. So in terms of logarithms, the first thing we need to understand is the definition of a logarithm. We're getting this from page 606 in your book. It says, suppose b is greater than 0 and b is not equal to 1. For n greater than 0, there is a number p such that log base b of n equals p if and only if b raised to the exponent p equals n. Now this is the formal definition of a logarithm. But if you don't understand, and it's very simple, but if you don't understand what the parts are, then it's kind of complicated. So I'm going to explain it. B stands for base. The base of an exponent is the lower part of that power, right? N is your number. For example, 3 squared equals 9. 9 is the number that stands alone. Okay, p is your exponent. So if I did 3 squared equals 9, the squared is the p. That's your exponent. So here's the thing. Your b value, or your base, has got to be greater than 0. In other words, it can't be negative. And it cannot also equal 1. So if it equaled 1, then it wouldn't make any sense. Alright? Because 1 to any exponent is just 1. That's a special case that we're not dealing with. Okay, so our number, our result, basically, has to be greater than 0. There is a number p, the exponent p that is, such that, and here's how you're going to read it. And I'm going to go to the next slide, and you can copy this down. But you're going to read this as log base b of n equals p. I'm going to write it in its notation, log base b of n equals p. And then base b to the p exponent equals n. b to the p equals n. So this is how we read it. So finish copying that down. The number one thing that we need to understand when it comes to today's lesson is how to convert from a logarithmic function to an exponential function. And we need to understand that they will undo one another. They are inverses or opposites of one another. So they're going to be used hand in hand. We're going to read a log function as log base b of whatever the number is equals p. P represents the exponent. An exponential function, we're going to read it as the base b raised to whatever exponent equals n, the number that stands alone. Now here's an example of how we convert. So x cubed equals 27 is an exponential function, or an exponential equation. But we can convert that to a logarithmic equation. We can say log base x, notice the x, our base, of the number 27 equals the exponent 3. We can just take the pieces and convert to the other form. So these are inverses. In other words, they will undo each other. All right, so let's take a look at the next slide. Now, this is another example where we are converting from one form to the other. In this one, we're converting from logarithmic form into exponential form. So I'll let you copy that down, then we'll discuss it. Okay, so if we have the expression log base 9 of x equal to 3 over 2, we can convert that to exponential form and then actually find our answer. 9 to the 3 over 2 equals x, which happens to be the square root of 9 cubed, which is 27. Now the calculator will easily do 9 to the 3 over 2 exponent. Now, how do I know when I need to convert to exponential form? Well, if they don't give me part of my log, then that tells me automatically I've got to convert to exponential form. I don't know what x is, and that's over here with the log. If I did know what x was, I could just put log base 9 of whatever it is in the calculator, and it would give me the answer. I could just evaluate it. But since I don't know what x is over here with the log, I need to convert to exponential form. Okay, let's go to the next slide. All right, in this problem, we've got log base 4 of 256 equals y. In this case, don't convert because the variable is the exponent. All right, in other words, all I have to do is plug it into the calculator and I will get my answer. Okay, so how do we put this in the calculator? Well, it's very simple. You are going to use the math function. Y'all listen up. So I'm going to press the math button and then go down until you see log base. Everybody see log base? Press enter. And then you can plug it in. You see the little squares? The base is the first one. And then the number is the second one. Press enter and you should get 4. Just plug it in. And y equals 4. Alright, is everybody with me on that? So in this example, I said solve, and I want you to solve 3 to the x plus 7 equals 5 to the 2x. But there's an issue here. What is our issue? Different bases is the problem. Now, last week, we learned how to convert from, if we had different bases, we converted to the same base. But we had to be able to convert to the same base. Can we convert 3 and 5 to the same base? No, because they're already primed. They are as simple as they can get. So, now I can use logs to solve this. Now, we're not quite ready to do what we need to do to solve this problem. But this is why we have logs. Logs allow us to solve problems, exponential equations, where the bases are different. So we'll be doing that later. So the property to quality for logs was very similar to the property to quality for exponential functions, and they should be because they're inverses. They are opposites, so they undo one another. So if I have log base b of x1, and that's equal to log base b of x2, since the bases are the same, then x1 is equal to x2. There's no difference from me saying b, if I said b to the x1 equals b to the x2, which is exactly what this is, basically, all right, then x1 will be equal to x2, right? Well, it's the same concept when it comes to logs. Alright?
That was good.
Alright, so let's move on to the next thing. Okay, the next thing example says log base 4 of 21 equals log base 4 of x. So this is the example that goes with the property. So if my bases are the same in the logs, you might as well just go ahead and cancel those out and say x equals 21. That's how easy this is. If the log bases are the same. If they're not the same, then that's going to require us to use some other rules, which we're not ready for yet. So, we're not going to see any today where the bases are different. The bases are going to be the same today. Alright, let's move on. Okay, so here we have some examples. Now, guys, I'm taking these examples straight from page 606 in the book. And it says convert, well, it actually says write. Write or convert in logarithmic form. So here we've got 3 problems that are in exponential form. So I want you to take a minute, based on what we just learned, and write these in logarithmic form. Do that now. Let's see what you got. Okay, converting to logarithmic form. Philip, what should this be?
I ain't know.
How about log?
Log
Base 3
base 3
of 27 equals 3. And why is that? Because 3 is the base.
Because the calculator said it.
No. Because 3 is the base. 27 is the number. And 3 is the exponent. So I take those parts and plug it into the basic log form, and I get my conversion. All right? Number 2.
Maybe,
Log.
yeah, log
Maybe base 2.
2 and then 32.
32.
And then equals 5.
There you go. So easy. All right, what about here? Log. 4. 116.
I don't know that one.
Boy, y'all look good. There you go. Now, you've done this. This was exponential to logarithmic. How about we do logarithmic to exponential? Do it.
Man, see that Cole, you always be doing this.
What the? No.
So, in this problem, we are converting each of these equations that are in logarithmic form into exponential form. And it's just very basic. So what are we doing? We're going to take our base, which is 5, raised to the exponent, 3
Equals
equals
125.
125. Over here, base, 8, exponent.
Equals 4.
Okay, so what does 8 to the 2/3 mean? It means the cube root of 8 squared. So the cube root of 64 is 4. All right, and then 10. Now, 0.001 is really 1 over 1,000. And that's what 10 to the negative 3 is. All right, let's look at the next thing. Okay, and these problems are going to evaluate each expression. So we're going to be using our calculators. Let me write these down.
That's not the problem.
No, yeah, that's the problem.
I thought they were easy.
3 cubed equals 27 is the first one. No, I said that wrong. Sorry. Wrote down the wrong thing. Okay, so here we go. Log base 3 of 1 over 27. Number 8. Log base 16 of 4. And then 5 as our base. Raised to the log base 5 of 25. Okay, so that's a little different. So solve those problems now. So log base 3 of 127 is what? Okay. All right, log base 16 of 4. And then, remember, you're going to do 5. In your calculator, you're going to do press the 5 button. And then the little exponent button. And then go to math and go down to log base. And then up here you'll have log base 5 of 25. And then what do you get? 25. Now, here's the thing. Log base 5 of 25 is like saying 2 to the what exponent equals 25? Well, it'll be 2 squared, right? So, this would be 5 squared. I said 2 squared, I meant 5 squared. 5 squared equals 25. Okay? Alright, look at the next one. Solve each equation or inequality and check your solution. Now, the first one is log base 7 of y equals negative 2. The next one is log base b. Log base b of 64 equals 3. So solve those two equations. Alright, so in the first one, log base 7 of y equals negative 2. Now we can't just plug this in the calculator. That's not going to do it. What we've got to do is convert it to an exponential function. So the base is 7 to the negative 2 exponent equals y. Now we can put that into the calculator. Now, what is 7 to the negative 2? It's really 1 over 49, right? 1 over 7 squared, which is 1 over 49. So you can leave it as 1 over 49, and that's the way I would rather you do it, 1 over 49, instead of using the decimal. So if you get the decimal, there is a way to convert it. The way that you convert it is you're going to use your alpha y equals, and then number 4 says F arrow D. That means convert from decimal to fraction or fraction to decimal. You can do that. All right, number 11. Our base is b. Our exponent is 3 equals 64. Now, to solve a cubic equation, take the cube root of both sides. Your calculator will do it, but the cube root, remember you got the little index there. The index is 3. The cube root of b cubed is just 3. I'm sorry, b. And the cube root of 64 is 4. So b equals 4. Good. All right. Next thing. Try to solve the first one. The first one should be very easy. You can just evaluate it in the calculator. The second one should also be very easy because you've got the same base on both sides of the equation. Okay, so go ahead and do this. Stuff, guys. All right, so in the first one, you can just plug this straight into the calculator because everything we need is here on the left side. There's no variables on the left with the log. So what's the answer?
-3.
Okay, so x equals -3. All right, number 13. For this problem, since our bases are the same, treat it kind of like we have common, well, it's the same thing as doing an exponential equation with the bases the same. Just cancel out the log base 5. So 2x minus 3 greater than x plus 2. Now you just solve it like an equation. Subtract x. So x minus 3 greater than 2. Add 3. X greater than 5. Now when we check ourselves, we have to plug in a number greater than 5, like 6 or 7 or 8 or whatever. So if I plug in 7, let's say I plug in 7. 2 times 7 is 14, minus 3 is 11. Alright, over here, x plus 2, 7 plus 2 is 9. So wouldn't it make sense if I take log base 5 of 11, it would be greater than log base 5 of 9? Yeah. Okay, so this is a true statement. All right, next problem. I've actually accidentally done it for you. Let me get rid of that. Okay, so, but you're doing the same thing here, guys. You're going to cancel the log 10s, log base 10s, and then solve the equation x squared plus 36 equals 100. So go ahead and do that. All right, so we're going to set x squared plus 36 equal to 100. There you go. So the quadratic equation would be x squared equals 64. Take square root of both sides. Now we're only going to take the positive value. Well, I take that back. You can use the positive or the negative. So I said in the previous class, just use the positive. So for right now, we'll just use the positive value. But technically, you could use the negative because if I plug in negative x and square it, I'm going to get 64 just like I would if I did positive x. So we'll see how that goes out as we continue. All right, now look at this one. Here we've got log base 3 of 3 to the 2x minus 1 equals 7, and we need to solve this. Look what happens. When we use the formula to convert to the exponential function, I take 3 to the 7th, base 3 to the 7th, equals the number which was 3 to the 2x minus 1. Then what happens to the bases? Go away. So 7 equals 2x minus 1. So we're going to add 1 to both sides to give us 8 equals 2x, and so x equals 4. But this raises an important issue for us, and we're going to see this more closely tomorrow in more detail. Whenever I have a base that's equivalent to the base of the number that I'm dealing with, so in other words, log base 3 of 3 to an exponent, or just log base 3 of 3, the final result will be whatever that exponent is. So here I've got log base 3 of 3 raised to the 2x minus 1. If I had log base 10 of 10 to the 2, what would that simplify to? 2. If I had log base 103 to the 103, let's see, x minus 1, what would it simplify to? X minus 1. We're going to see this property used more frequently as we go. Does everybody have this? All right. So here's your homework. Page 609. You're going to do 22 through 27 all. You're going to do 31 through 42 all, except not 41. Okay? 41 is too advanced for us. All right? So you're not going to do 41. We'll learn how to do 41 later. But the ticket out the door is 23, 25, 37, and 40. So go ahead and get started on those.